Hello everyone. Today we're diving into two fundamental principles in software engineering: inversion of control, or IoC, and dependency injection, or DI. These concepts are crucial for building flexible, maintainable, and testable applications, especially in object-oriented programming. At its core, inversion of control is a design principle where the control of object creation and lifecycle management is inverted. Instead of your code creating its dependencies, a framework or container takes on this responsibility. Think of it as handing over the reins. In traditional programming, your code dictates the flow. With IoC, an external entity dictates the flow, calling your code when it needs to. This inversion leads to a more decoupled architecture, as components no longer directly manage their collaborators. They simply declare what they need, and the IoC container provides it. Dependency injection is a specific implementation of IoC. It's the technique of supplying an object with the instances of objects it requires, its dependencies, rather than having the object create them itself. Essentially, instead of a component reaching out to get its dependencies, the dependencies are pushed into the component. There are three main types of dependency injection: constructor injection, setter injection, and interface injection. Both IoC and DI offer significant advantages. First, modularity. Components are less coupled, making them easier to develop, understand, and reuse independently. Second, testability. It becomes much simpler to mock or substitute dependencies during unit testing. Third, maintainability. Changes to one component have less impact on others. And finally, flexibility and extensibility. It's easier to swap out different implementations of a dependency without altering the core logic. Let's look at a Python example to illustrate the problem that DI solves. Here, our car class directly creates an engine object. This means car is tightly coupled to engine. If we wanted to use a different type of engine, say an electric engine, we'd have to modify the car class itself. Now, let's refactor this using dependency injection, specifically constructor injection. Notice how the car class no longer creates the engine. Instead, it receives an engine object as an argument during its initialization. This makes car independent of the specific engine implementation. We can now easily use a combustion engine or an electric engine without changing the car class. In summary, inversion of control is a broad principle where the control of object creation and flow is inverted from your application to a framework or container. Dependency injection is a concrete pattern that implements IoC by providing dependencies to an object rather than having the object create them itself. By embracing IoC and DI, you build more robust, flexible, and maintainable software systems. If you found this explanation helpful, please give this video a like and subscribe to our channel for more programming insights. Thank you for watching.